Dale alegría tu cuerpo por las orejas. Hey, let's do statistics. Yeah. All right, let's recap. This is going to be a new example where we talk about the number of siblings. Some people have 0 siblings, that's 20% of them, all the way up to 5 siblings. What happens to those people who have more than 5 siblings?
You do not talk about
those people, okay? We're trying to keep our table short. So first thing I want to do is let's fill in the capital F of x, the cumulative distribution function, because that's going to make it really easy to figure out what does this k need to be so that this adds up to be 100%. And that way we get our 0.05 there. Let's talk about mode. Mode is the one that's most likely. Most people have 1 sibling. When I say most people, I mean that was the scenario that was most common. What about median? Well, here at 0, we're not up to 50%. Here at 1, we're not up to 50%. It's not till we get here at 2 that finally we've passed into 50%. So our median is 2. For the mean, let's find the expected value by taking each of the probabilities times that value of x, and we get 1.95 as our mean. That expected value of x has a name. Sometimes it's called the first moment. The idea of a moment is you're collapsing the whole data set down to one particular thing, one instance, one number. And this 1.95 can be thought of like the center of gravity for something. So if you wanted to take a big thing and collapse it to one moment, you'd think about center of gravity. There does exist a second moment. You get that if you take the x values and square them. So the 0, 1, 2, 3, 4, we're going to square each of those and add those up. That's 6.05. When you square things, you're talking about the area. So this 6.05 is really hard to picture because it's in siblings squared notation, but it's still going to help us talk about how spread out it is. In fact, the calculation for variance is based off that second moment minus the mean squared. A lot of books see this notation and feel like there's just too many parentheses there. So you can also write it like this, where the squared goes right here on the E. For this data set, the 6.05 minus the 1.95 gives us a variance of 2.2475. That's still kind of hard to picture what it means because we're still in the siblings squared units. So it makes more sense to talk about the standard deviation, which is just the square root of that. And yes, we're talking about the population standard deviation because we have all the probabilities for the whole thing. So that's sigma, just like when we talk about expected value of x, we're talking about mu here. We're not working with data, we're working with the probability distribution function for the population. Does this make sense? From the average of about 2 going out 1.5 each way, we're getting a good chunk of the data if we go out a second standard deviation. So from 2 plus or minus 3, we get nearly all the data. Okay, this looks reasonable for a standard deviation. And if you're really into mathematical proofs, there actually is a way to take this equation that we're used to when we talk about data, take n in a limit as it goes to infinity, and you will end up getting the same idea here to show you that they are related. This is the second moment. This guy has a name. He's the second centralized moment because it's centered around x bar right here. You don't need to know that definition. What you do need to understand is the idea that the first moment tells you where the data is at. The second moment tells you how spread out it is. And as you might have guessed, there is such a thing as the third moment that talks about how skewed it is, left or right. There's also a fourth moment which talks about kurtosis. That's how quickly do the probability tails level out to 0. What you need to understand is simply that there are moments, and you calculate them by taking x to the power of whatever moment you're looking for. In this class, it's going to be usually the first or second moment that we're most interested in. And the more moments you have, the more you're describing all the little details about that probability distribution. So in our list of tricks for working with discrete data, we can find the expected values, we can find the second moment, the median, and we can calculate standard deviation.